Two positively charged masses are separated by a distance r. Which statement best describes the gravitational and electrostatic forces between the two masses? So we often see this comparison between the electrostatic force and the gravitational force, and that's because the equations to calculate both forces are very similar. So the gravitational force is the gravitational constant times the mass of one object times the mass of the other divided by the distance between them squared, while the electrostatic force is k, another constant, times the charge of one object times the charge of the other divided by the distance between them squared. So we see that both forces are inversely proportional to the distance between the objects squared, and both have this constant as well as a product of properties of the objects in question. So that's why we often see these comparisons, but we can also use these equations to help us solve this problem. So since we know that both masses are positively charged, we know that like charges repel, we can determine that the electrostatic force will be positive, since we'll have positive charge times a positive charge, which indicates what we've written here, that the two masses will be repelled by the electrostatic force. So the electrostatic force in this case is repulsive, and we know that the gravitational force is always attractive. So the gravitational force always pulls masses together, while the electrostatic force can be repulsive or attractive depending on the signs of the charges. So if we have opposite signs, the force will be negative, which indicates an attractive force. If the signs are the same, the force will be positive, indicating a repulsive force. In the universal law of gravitation, we don't have that sign convention because we know that the gravitational force is always attractive. So the correct choice here is that the gravitational force is attractive, it's always attractive, and the electrostatic force is repulsive in this case since the charges are the same.